A confirmation about the audio, please, guys. If you're able to hear me out perfectly well. Thank you. So I hope you would have had a hearty lunch break, but I hope that the lunch was not heavy enough to put you to slumber or sleep. Because after this, the portion that we are going to enter is going to be a bit theoretical. But before the break, we managed to finish some of the very significant conceptual portions. I would again request all of you to have the same aspect, the same approach. Few of you already follow that. So I would ask you, I would recommend you to try to write it in your own words, what you have basically come across in the session, in the duration of the session, all the various concepts that you have come across. That is going to be very, very rewarding in the long run for your examination. That is going to the portion and to the depth that we have covered the monsoon. That is at par, let me tell you, at par with the requirement of even the optional subject of geography. So just consolidate this much amount of portion, and please understand the depth that we have been to. UPSC is never going to venture to those depths. So you will always have a kind of an advantage over your competitors, over your peers, and over the rest of the candidates who have not read in this much amount of depth. So hold on to that advantage, and that will be only materialized if you are able to write it in your own words. So try to do it immediately after today, maybe latest by tomorrow. Otherwise, mind has got a very beautiful way to function. Mind grasps things, and at an equally faster rate, it ends up losing things as well. So I'm sure you have many other engagements in your life. Don't let those mar the different concepts that in a very difficult manner you have managed to put inside your mind. Okay, so now we carry on with the aspect of the Indian monsoon. So here the tropical easterly jet. Now this tropical easterly jet we have already seen that once we have the onset of monsoon, the tropical easterly jet generally is observed, is experienced after the onset, because the heating of the Tibetan highland usually takes some time. So it is in the later half of June and the first week of July when the tropical easterly jet becomes active. Okay. So when this becomes active in general, becomes active generally after the onset. Now, without the tropical easterly jet, also India will be receiving that much amount of rainfall. But once the tropical easterly jet also comes into play, this further strengthens the low pressure. Okay. Now there is another temporary jet which is also at play, and we can talk about it. If we are comfortable up till this point, we can again elevate the level a bit, and as long as you are comfortable, I will continue to elevate the level. The moment you feel that you are out of your skin, moment you feel that this is going into an area where you are not comfortable, feel free to point it out. There is another temporary jet stream which comes into play during these months of June, July, and August. And that is largely generated because of the active low pressure that you find in the region around Arabian Sea and Western Indian Ocean, and also the activated low pressure across the ITCZ. Always remember, this is the ITCZ during the months of the monsoon. So there is another temporary jet stream which is in existence, and that is the Somali jet. Somali jet stream. Now, this Somali jet stream is named after the region where it tends to originate. Now, what happens is that simultaneously during these months, this is the Horn of Africa, guys. This is what is regarded as the Horn of Africa. You have Eritrea, Djibouti, Somalia. These are the countries situated at the Horn of Africa. Now, during the summer months, what do you think? Will this get heated up significantly, or will that remain cooler in general in terms of temperature? What is your normal perception if the ITCZ is through here during the summer months? What do you think will happen to the Horn of Africa? Perfect. It will get very heated up. So there also, you will find an active convection taking place over the region of Somalia. So here, active convection due to excessive heating. Convection, whenever I say active convection or whenever I say intense convection, that basically refers to the same phenomena, rising of the wind because, or rising of the air column, because the land gets very heated, the air above it also gets significantly heated up. So this active convection due to excessive heating means air rises up. Air rises up not at the same level as the case with tropical easterly jet. Why not at the same level? Because the tropical easterly jet originates from the region of Tibetan highlands, which is already at 5 kilometers from the sea level. So for the air to rise up from Tibetan highlands, that air will immediately reach the level of tropopause, and then it will start diverging. But in the case of the region of Somalia and Horn of Africa, you don't have the similar phenomena. So comparatively, a lower altitude in respect to the tropopause. Lower altitude not means the surface. So if you have to think about it, let's suppose if this is the ground surface or the sea level, here let's suppose this is the elevation at which the tropical easterly jet is moving. Somali jet will be moving at a lower elevation comparatively, still significantly higher up above the ground, but slightly lower as compared to the tropical easterly jet. Now, these jet streams, they are named as jet streams because they are moving at a higher elevation and they have a speed of around 80 to 90 kilometer per hour. These end up moving towards the region of India. They will cross the Arabian Sea. Now, this Somali jet has got a kind of a dragging effect. Dragging effect means it drags the rest of the wind along with it. So when this Somali jet is active, it will drag more winds towards the Indian coastline. And if anything drags more winds to the Indian coastline, means beneficial for rainfall in India. More rains in India are observed as a result of that. So that is why Somali jet is beneficial for monsoon rains. Okay? It is generally beneficial for the monsoonal rains. But this Somali jet stream is not always active. Only in rare cases where the region of Horn of Africa has got excessively heated up, that is when that active convection will come into play. And this wind will have a dragging effect. This is the Somali jet. So this Somali jet stream drags the other winds to cross the Arabian Sea and bring rains to India. Now, why is it that Somali jet is trying to move towards India? Is it because they know that India is a very good place, people are very nice, culture is very nice, the food is very nice? Is that the reason? Absolutely not. The Somali jet is moving towards India because the winds, they only know the high and the low pressure systems. You have a very intense low pressure system around the region of ITCZ. So that is where in the region of ITCZ, we have already talked about that wherever you have a monsoonal trough, and if that coincides with the ITCZ, there is a convection happening at the upper elevation as well as at the ground surface. So that Somali jet targets the upper level of convection. That is why it comes towards India, it comes towards ITCZ, and that is where it brings more rainfall. Positive IOD and Somali jet act simultaneously in majority of the cases, but not always. So Avni, you also had the same question that Horn of Africa has the same phenomena as positive IOD. Sometimes it has, but sometimes it can happen that this portion of Horn of Africa has got heated up, but simultaneously the eastern portion of Indian Ocean, let's say, has been heated up even more. So in those situations, you can have a negative IOD, but a Somali jet which can be prevalent. But mostly, in majority of the cases, when you have a Somali jet, you will find the presence of a positive IOD along with that. Okay? Then the impact of El Nino and La Nina, we have seen that El Nino always increases the amount of rainfall received by India or reduces the amount of rainfall received by India. Amount of rain in India, and La Nina increases the amount of rains in India. Okay. In the case of IOD, also we know that the positive phase will be beneficial. Positive is beneficial, and neutral and negative. Neutral and negative, they are disadvantageous for rainfall or detrimental to the amount of rains of rainfall experienced. Okay. Now we have taken a look at the factors leading to the monsoonal rainfall. We have taken a detailed look into the how the rainfall happens, the onset of monsoon. Why is it that every year we don't have a fixed date for the onset of monsoon? If the conditions are so very similar that ITCZ will shift, it will bring rainfall, still we have variable date for onset of monsoon every particular year. It is not fixed. That is because the onset is determined by the disappearance of the southern branch of the jet stream. The southern branch, let's say, can disappear today, and the onset will be, let's say, 5 days from now. The southern branch can be present till the first week of June. The onset will then be after the first week of June. So that is where onset is something which is very, very variable. We have taken a look at the mechanism of the advancing monsoon as well. Now, anything which comes eventually retreats and goes back as well. And that is the case with the monsoon as well. So now we come to the aspect of retreat of monsoon. Anshu, how is Somali jet related to tropical jet? Somali jet is not related to tropical easterly jet. Both of them act independently. Tropical easterly jet originates from the region of the Tibetan highlands, moves at the level of tropopause. Somali jet, slightly at a lower elevation, originates from here. Its direction is southwest to northeast. Its direction of Somali jet is very similar to that of the monsoonal winds. Okay. Nitin, it seems that whole world works to bring monsoons to India. On a lighter note, you can think about that, but at the same time, imagine that all these factors have a very complicated interplay, And despite all these factors, sometimes you receive lesser than average rainfall. It is not only about the total rainfall received during the monsoon months, it is also about the distribution of rainfall. If, let's say, as we observed in 2022, if you take a look at the total rainfall received in 2022, it is fair enough, slightly higher than average. But June was extraordinarily dry, which meant that sowing of rice was delayed. And July was extraordinarily wet, which meant all the areas were flooded. So rice cultivation suffered because of that. So if everything works properly, then you have a kind of a uniform distribution. That is where climate change is having an impact, and a very apparent impact over India. And climate change is happening in the real term scenario. If you take a look at it, climate change is disturbing the monsoonal distribution, the rainfall distribution, due to which the areas, they suffer from concentrated spells of rainfall. If it will rain, it will rain very heavily. Your region, your city, your street, your village will flood. And then after that, 10 days of absolute dry conditions, maybe drought like conditions, they emerge. So that is the impact of climate change. Also, due to climate change, all these jet streams, all these phenomena, they are becoming irregular and highly unpredictable. For example, 2021 was again a La Nina year. We expected a higher than average rainfall, but suddenly the month of August was very dry. Obviously, as we talked about it yesterday as well, Indian Meteorological Department, after the month of August passed, in the later week of August, Indian Meteorological Department very easily issued a kind of a statement that, you know what, August is very, very dry. August has been very dry because of the sudden reappearance of the southern branch of the jet stream. Now, that is how unpredictable the weather systems are, and that is how our prediction models are also significantly unreliable. We generally end up doing the post-mortem analysis rather than approaching them in a manner which is predictive enough. We are unable to predict, we are able to only analyze. So that needs to change in order to bring about a better reliability in terms of agricultural output, drinking water shortages, and so on. Okay, Ajit, I hope now that you get your answer about the question that how climate change affect the Indian monsoon. It is becoming very unpredictable, concentrated spells of extremely heavy rainfall followed by a prolonged dry season. Then we talk about the retreat of monsoon. Retreat of monsoon. Retreat means going back. Anything which comes when it goes back, that is what is regarded as retreat. Now here, basically, if you will observe, first of all, the ITCZ. First of all, the equator. Let's suppose. Now the ITCZ, during the month of June up till July even, ITCZ lies somewhere here. Then August, September onwards. September is when you have the condition of equinox, and after September begins the southward march of the sun, where the apparent position of the sun is in the southern hemisphere. So from September onwards, generally after 17th of September, the monsoon begins its retreat. And that is when the monsoons, they initially, it is the ITCZ which starts coming down. Now, once the ITCZ starts to come down, that would mean the initiation of the northern branch of trade winds as well, which we did not consider up till now, which we have not considered as a factor in Indian monsoon till now. So, as this entire system of ITCZ starts its downward march or southward march, first of all, it initiates around middle of September. And this is a very slow process, a long drawn process. The withdrawal of ITCZ is a very long drawn process. Now, this would mean that the winds, they are coming towards the ITCZ. They will no longer be going towards the northern parts of the country. Meanwhile, the northern trade winds, they will also start getting active. Now, in majority of the portion, the northern part of or the northern trade winds, they are going to be absolutely continental. So they will be very dry. Continental means they are moving over the land masses. So they won't have any place to pick up the moisture other than these areas. Now, as they will cross the region of Bay of Bengal, they will pick up as much amount of moisture as they can. And all that will be dropped here in this region of Coromandel coastline. So that is why Coromandel coastline receives rainfall, or the Tamil Nadu coastline starts to receive rainfall during the retreat of the monsoon. Retreat, oftentimes, let me write it down so that you don't get confused. Retreat is initiated in the second half of September right? It is a long drawn process where the ITCZ begins its march or its movement towards equator. Okay? Then after that, we can think about it that generally the process lasts for 2 months. Okay? Coromandel coastline receives rains during retreat. What is the general direction of wind over India during this season? If you observe the general direction of wind, that is general direction of wind is northeast to southwest. So as you can see that the wind movement has completely reversed. The wind movement has completely reverted. That is perfect monsoonal condition where the seasonal reversal of winds are experienced. Now this oftentimes, it starts from 17th of September onwards. It continues up till mid of November, end of November even. Right? Now, because the wind motion is from northeast to southwest, that is why you will find many of the books also and many of the videos available on YouTube, many of the various faculties, many of your various study sources and materials, they will tell you that this is northeast monsoon. But that is not the case. Northeast monsoon is very different. We'll come to it. But here, this is about the withdrawal or the retreat of the monsoon. Understand, retreat is a kind of a withdrawal process where the ITCZ starts withdrawing from India. As the ITCZ was advancing to India, advancing monsoon. As it is withdrawing from India, retreat of monsoon. Just to give you an idea about the process of retreat, observe that the process initiates generally around 15th of September, 17th of September generally. 1st of October, this is where the monsoonal trough, the ITCZ, sometimes lies. 15th of October, November, 15th of November, 1st of December, and so on. So it carries on for a considerable duration. That is why even during the month of November and December, because the low pressure system lies over the Indian Ocean, that is why November, December is also a cyclonic season in the region of Bay of Bengal. Okay? So due to the retreat of monsoon, which areas receive rainfall? You have the region of Coromandel coastline. Coromandel coastline doesn't receive rainfall during advancing monsoon. Okay? Now, I hope we are comfortable till here. Now let us understand what do we mean by the northeast monsoon. Again, one of those phenomena where majority of the book types will mention that retreat of monsoon is the northeast monsoon. But that is not the case. Regardless of any scientific paper that you check, any research paper which is published that you check, even the Indian Meteorological Department's prediction that you check, northeast monsoon and retreating monsoon, they are different. The only similarity is the direction of the wind movement. But what happens, why it happens, when it happens, it is a very different phenomena. So listen to this carefully and don't get bothered by the various different types of concepts which are thrown at you through various different videos and study materials. Think about it and listen to this carefully. So here, when we talk about, let's say, first of all, the equator. Now, this northeast monsoon is observed during the months of December and January. Now, what happens during these months? In fact, from the later part of October itself, the process of cooling is initiated because the ITCZ starts its march to the south. By the month of November, many portions, they get significantly heated up. Which portion in particular? So here to the northwest of India, what lies in the region of Pakistan, in the northern provinces of Pakistan, here you have a plateau kind of region, a highland kind of region. The name is Potwar Plateau. Now this Potwar Plateau, that is surrounded by mountains, present at an elevation, so it starts losing heat very quickly. And by the mid of November, this becomes very cold. Becomes cold by mid-November. Now, when it becomes cold, it will start generating a high pressure. High pressure zone means winds originate from that area. Winds originate from that area. And they will move in all different directions. Winds will move here, winds will move here. But we are not interested in these winds. We are interested in the wind which originates in this direction. Now, by the time of end November and December, ITCZ already places itself somewhere around here. Let's assume that in December, let's assume that this is the ITCZ which has developed, or in fact, if you want to go for the accurate mapping, let's assume that the ITCZ is somewhere here. during the month of December. Now, the winds have originated from Potwar Plateau. Now, their destination will be what? ITCZ. That is where they want to reach. And being in the northern hemisphere means the winds will be diverting to the right. Right? So the winds, they shall be diverting, deviating to the right. Some of the winds, they manage to enter through the funnel area into the northeastern hills. Now, whatever little amount of moisture that they have, they will bring precipitation there. But the winds, aided by the mountains and the rightward bend due to Coriolis force, they initiate a motion. Yes, Vivek. They initiate a motion towards ITCZ. Now, majority of the areas in this case, they will not experience any rainfall because all this region that you see across the entire landmass of India, winds have no place to gain moisture and bring rains. So the rest of the country will be mostly dry. But then some part here, they will bring some amount of rainfall because they are trapped in the hills. So orographic effect will happen, little amount of rainfall. But here, across the Tamil Nadu coastline, you will have sufficient amount of rainfall received. What is the direction of the wind movement in this case? Direction of wind movement is northeast to southwest. Of wind is northeast to southwest. That is why this is also what is referred to as northeast monsoon. This is different from the retreat of the monsoon. This is different from the withdrawal of the monsoon. The impact is largely the same. The impact in the sense it causes rainfall across the Tamil Nadu coastline. Causes rains in Tamil Nadu coastline. That is where in Tamil Nadu, when you have these rains, those of you belonging from the state would adhere to the fact that in Tamil Nadu, when you have the onset of rains during this time, generally around the second week of December, that is when you have the sowing of the rice crop. The paddy crop sowing season starts around 15th of December onwards. So that is basically the role played by the northeast monsoon. Why winds move towards the northeastern states? The winds move, see, the general movement is they will be hugging the foothills of Himalayas. All the meanwhile, they will be deviating slightly to the right due to the Coriolis force. But some of the remnant wind will end up reaching the region of the northeast. Benita, so Coromandel coast receives rainfall from northeast monsoon, but not from retreating monsoon. Retreat of monsoon, remember, Coromandel coastline receives rains during the retreat because that sets in the kind of northern trade winds which will pick up the moisture from Bay of Bengal and will cause rain. So Tamil Nadu coastline receives rainfall due to both of these factors, but majorly northeast monsoon is also responsible. So Namita, Tamil Nadu receive rainfall because moisture is carried from Bay of Bengal? Yes. As they move over the water bodies, these winds become onshore in the region of Coromandel coastline. That is why they bring rainfall. In retreat of monsoon, where the winds do originate, it is a part of, during the retreat of monsoon, it is a largely part of Hadley cell in the retreat. So Hadley cell means the trade winds will be in effect. So that is where the subtropical high pressure belt in the northern hemisphere, that starts generating the wind. Retreating to have northeast to southwest winds? Yes, Abhijit. The wind direction is same in the case of retreat of monsoon as well as in the case of northeast monsoon. In case, in situations where you find the northeast monsoon too difficult a fact to remember, don't get bothered by it. Just the normal idea about what is the retreat of monsoon, that will also be sufficient enough. Okay? Any other doubts that you have? Okay. So now we come to the break in monsoon. We have already discussed why break in monsoons happen, because the direction of the wind suddenly change after causing significant rainfall in a region. The directionality of the winds, they end up changing. So here, after rainy periods, if rain fails to occur for 1 or more weeks, it is known as break in monsoon. Now, dry spells are quite common during the rainy season, and the breaks occur because of different reasons. One, that in northern India, rains are likely to fail if the rain bearing clouds are not very frequent. Rain bearing storms are not very frequent over the ITCZ over this period. Now, this rain bearing storms, this is the trough that we were talking about. These rain bearing storms, when we talk about, this is the monsoonal trough that we were talking about. Monsoonal trough. Okay, so monsoonal trough is not very common. So sometimes you don't have very active low pressure. So that is why sometimes rains are not received. Sometimes it also happens that there is another low pressure which develops after a region has received rainfall for some duration. Another low pressure develops. So the winds, rather than approaching the earlier low pressure, they change their direction, due to which certain areas, they are devoid of rainfall. Okay. Now, here, before moving on into the aspect of pre-monsoon shower, I have a question from Ajit. That is, in which part of India receive monsoon first and receive last? So basically, if you think about it, the rainfall is received first by the Kerala coastline. That is where the onset is declared, right? So always Kerala coastline will receive the first rainfall. Then the monsoon reaches last in the region of northwestern part of India. It is in this entire area that the monsoon reaches last. And it is that area where the monsoon starts to withdraw first, significantly faster as well. So northwestern part of India, that experiences the monsoon condition for the briefest amount of duration. Utkarsh, only winds are the reason for what, Utkarsh? Anshu, monsoon trough is a low pressure area created due to heat. Yes. Okay. Then we come to the portion of pre-monsoon showers. Pre-monsoon showers, that is something which happens before the monsoonal rains they hit. The rainfall that you receive, especially during the month of May, right? When you have significant amount of heating of the landmass, so you start to receive some amount of rainfall. That is pre-monsoon showers. Now, these pre-monsoon showers, they are generally convective in nature. Generally convective in nature. By the way, another question, around the region of the monsoonal troughs, the air will come in, the wind will rise up and cause rainfall. What kind of rainfall will that be? During the monsoonal period, winds come, moisture laden winds, they come to the region of these monsoonal troughs. They rise up and they bring rainfall. What do you think? What kind of rainfall will that be? Okay. So I will give you another hint. Let's suppose this is the region of monsoonal trough. Okay. Winds will come in. Now, will they rise in a straight manner or will they rise in a spiral or a circular manner around this low pressure? If you have intense low pressure, will the winds rise up straight or will they rise up in a spiral manner? They will rise up in a spiral manner because it is a concentrated area of low pressure. So very good. They will rise up in a spiral manner. Now tell me what kind of rainfall will be caused around the monsoonal trough. Very good. Nitin. It will be a kind of a cyclonic rainfall, right? It will be a cyclonic rainfall. Around the monsoonal trough, you will experience cyclonic rainfall. It will not develop a tropical cyclone. Never will a tropical cyclone develop over a landmass. But around that low pressure, as you have circulation of the wind as it rises up, bringing rainfall, it is a cyclonic rainfall. So during the monsoonal months in India, we receive orographic rainfall, because of the Himalayas and the foothills of the Himalayas, the Western Ghats, and all the mountain ranges. We receive convectional rainfall, areas get heated up, air rises up, and we also receive cyclonic rainfall during the monsoonal months. Okay? Now, here, pre-monsoon showers, they are convective in nature because you have regions which get heated up. There itself, the air rises up. Generally, the air doesn't have to come from all directions. There itself, the air rises up along with all the evaporates that you have. Now, if the air is rising up in convectional manner, what kind of cloud formation will you observe? If the air is rising up in a convectional manner, what kind of cloud formation? Very good, Pranay. Nitin, good. Perfect. Beautiful. Utkarsh, Abhijit, Anshu, Dinesh, Vivek. Very good. So as the air rises up due to convection, you have a cumulonimbus cloud which is created. And this cumulonimbus cloud will always accompany thunder, lightning quite sufficiently. Right? Now, here, these pre-monsoon showers are associated with different names in the different parts of the country. Now, here in the region around Karnataka, Kerala coastline, here you have local winds from the nearby water bodies, that is the Arabian Sea, which comes in. Around that low pressure rises up, causes rainfall. That is what helps in the early ripening of mangoes. That is where you will start observing that in the region around the southern part of India, you will start observing the availability of mango season right from the month of April onwards, because it helps in early ripening of mangoes. So that is the mango shower. So towards the end of summer, there are pre-monsoon showers. Kerala and coastal areas of Karnataka, they are called mango showers as they help in ripening of mangoes. But it takes a much more deadly form, a much more violent form when it occurs in the eastern part. The air is generally drier, and on top of that, you have some amount of moisture which comes from Bay of Bengal. So you have very heavy thunderstorms, generally occurring in the afternoon after prolonged heating has happened throughout the day. During the afternoons, there will be formation of convective cumulonimbus clouds, very thick, very dense. It will almost block out the sun, create a darker condition, very dark condition. And that is when it will cause thunderous rainfall with a lot of lightning. That is what is referred to as Kal Baisakhi or nor'westers. In the region of Assam, Bardoli Sira, that is the name. So here, Kal Baisakhi, because of the calamity in the month of Baisak in the region of Bengal and Assam. Now, this pre-monsoon shower is also beneficial for crops such as jute, which require a distributed amount of very heavy rainfall. So jute cultivation is benefited along with rice cultivation also. Now in Assam, these storms are referred to as Bardoli Sira in general. Okay? Now, then we come to the winter season. Now during the winter season, here, again, if I have to first of all draw the equator, let's suppose this is the region of equator. Mango shower is a pre-monsoon shower which occurs in the coastal region of Karnataka and Kerala, which helps in early ripening of the mangoes. Later half of April, first half of May, it is a kind of a convective rainfall which helps in early ripening of. It is not a part of onset of monsoon. That is mango shower. Now suppose this is the equator and we are in the winter months. So in the winter months, the ITCZ comes, let's say, in this region. It is moving towards south. Let's suppose this is your ITCZ. Now, as the ITCZ is shifting to the south, even the subtropical high pressure belt will shift to the south. The entire pressure belt system will shift to the south, isn't it? Now, something interesting happens in the region of Mediterranean. But before that, understand that even the subtropical high pressure belt that will start shifting to the south. It exists somewhere around 25 to 30 degrees to the north. So let's suppose this is the subtropical high pressure belt. Let's suppose this is the subtropical high pressure belt. High pressure belt. Now here, take a look at the Mediterranean Sea. It is the winter months, right? So take a look at the Mediterranean Sea. Now over the region of Mediterranean Sea, if you compare it, let's say the temperature of Mediterranean Sea waters and the temperature of the European landmass, which of them do you think will be colder or warmer, or will they exhibit equal temperature? What do you think will happen over the region of Mediterranean? Mediterranean waters, will they be warmer, will they be colder, or will they have the same temperature as the European landmass? Water is warmer, land will be cold, right? So Mediterranean Sea, very good. So Mediterranean Sea is warmer and the European landmass is colder. Now, as the Mediterranean Sea is warmer, that means the air above it will also be a bit warmer. And the air above the European landmass, that will be colder. You will have the creation of a front. And that will lead to the creation of a frontal depression or a small frontal cyclonic condition. Now, here you will have the existence or the development of a frontal cyclone, right? Or an extratropical depression or low pressure. Now, that low pressure will mean that there will be cloud formation as well, because it is happening over water bodies, so a lot of cloud formation. Now, which are the wind types, permanent wind types, or the permanent wind system? Which is the permanent wind system which will be in prevalence around the region of Mediterranean at this time of the year? What do you think? Very good. You will have the prevalence of westerlies. Beyond the subtropical high pressure belt, you will have the prevalence of westerlies here. So the westerlies, they will be active. Even the subtropical westerly jet stream, that will also be active. Now this westerlies, what it will do is, the entire disturbance along with the cloud cover, etc., that disturbance will travel aided by the westerlies. They will move across Iran, they will move across Afghanistan, they will move across Pakistan, and eventually they will hit the Himalayan foothills. Now these are cloud systems along with a traveling low pressure. The entire low pressure is traveling with the help of the jet stream movement, with the help of the westerlies. Now, due to this, in the Himalayan foothills, especially in the region of Jammu Kashmir, Himachal Pradesh, parts of Uttarakhand, you have immense precipitation in the form of snowfall, and significant amount of snowfall is observed. Whereas in the plain regions of Punjab, Haryana, Delhi, Western UP, Bihar, sometimes even northern part of Bengal, sometimes all the way till the Brahmaputra plains of Assam, and even northern Rajasthan, all these areas, they will receive rainfall. All these areas, they will receive rainfall. Now, once, let's say, one of this disturbance has traveled, one of this entire low pressure circulation along with the cloud, everything has traveled. Now, that means, will that system come to an end? No. That means, again, you have warm air over Mediterranean, colder air over Europe. Again, there will be development of another frontal depression. Another frontal depression will travel. Now, this depression or disturbance is coming from which direction? From the direction of the west. As far as India is concerned, it is coming from the direction of the west. That is why this disturbance is what is referred to as western disturbance. It is a traveling low pressure system along with the cloud cover and the disturbance associated. While it will cause snowfall, again I will repeat, it will cause snowfall in the region of Jammu Kashmir, Himachal, Uttarakhand, rainfall in the region of Punjab, Haryana, Delhi, northern Rajasthan, eastern part of UP, western part of Uttar Pradesh, sometimes even northern part of Bihar, Bengal, as far as the Assam plains. Now, this makes the winter very harsh, much more harsher in the northern part of the country. Because you would have heard and come across the news headlines that it has snowed in the region of Himalayas and the winters across the North India, they are going to be harsher. It is because of this western disturbance. Now, this western disturbance is active in which conditions or in which months? So it is active in the month of November itself. November, you will come across, let's say, 3 to 4 instances of these western disturbances. December and January is the peak. December and January, you will receive 7 to 8 such disturbances. February onwards, again, as the winter starts reducing, February onwards, the intensity reduces. So February, you have, let's say, 3 to 4 again. March, you have 2 to 3. Earlier, April would never witness western disturbance. But this year, even in the month of April, even in the first week of May, we experience this western disturbance. So this is how climate change is playing out. Earlier, western disturbance would be finished by the month of February. But now, March, April, even this year in April, we had 2 incidents of western disturbances causing rainfall, 2 to 3. Even in the month of May this year, we had 1 incident. But that is not a general phenomena. Generally, you will observe the western disturbance months to be spread from November up till March. It is during this month of March, if it starts to rain. Obviously, when we talk about this traveling low pressure system, do you think it will cause thunder and lightning when they come to India? Or do you think it will carry out a kind of a continuous slow process of rainfall? Apply your logic. Now you know enough amount of information to be able to deduct this. So when these western disturbances come, do you think they will bring thunder and lightning, or do you think that they will be able to cause a steady and continuous rainfall? What do you think? What will be the answer? Very good, Pranay. Sometimes they cause significant amount of thunder and lightning because These are depressions, low pressure traveling systems. They can cause cumulonimbus clouds to be formed over this area itself. So sometimes they are associated with thunder and lightning. That is why in the region of Delhi, in the region of northern Rajasthan, for in the year 2020 and 2021, this happened. And that is where the social media is absolutely never to be trusted, especially for the source of information. In this low pressure traveling system, when it hit the region of Delhi and Rajasthan in the month of December, it was an intense low pressure which was traveling. So, along with thunder and lightning, you had hailstorm which occurred. And immediately, everybody started clicking the pictures and they said, and that was the famous tagline going around, why to go to Shimla, Manali when you have snowfall in Rajasthan and Delhi itself? But it was not a snowfall, it was a hailstorm. So sometimes this can also end up creating hailstorms in the process. In the month of March is when you have the harvesting season of wheat. Wheat is a kind of a crop which is sown generally in the month of late October, November, harvested in the month of March. Now, at the time of sowing of the wheat crop, it requires some amount of rainfall. So, the western disturbance helps the growth of wheat by bringing rainfall during that time. Even mustard, that is benefited by this rainfall which occurs. That is why across all these northwestern regions, you will find wheat and mustard to be grown significantly. Typically utilized in all the famous Bollywood movies, you would see that large areas of mustard farms and large areas of wheat farms. That is the specialty of this particular region, especially during the winter months. But then, as the crop starts growing, it requires very heavy sunlight, very bright sunlight. Rains destroy the crop. So when the western disturbance brings rain in the month of March, that causes a lot of destruction of the wheat crop. The standing wheat crop gets destroyed. So that is the aspect of western disturbance overall. So these are low pressure systems which originate over the Mediterranean Sea and Western Asia and move into India along with the westerly flow and hence are known as the western disturbance. They cause the much needed winter rains over the plains and snowfall in the mountains. So which area receives snowfall? Jammu Kashmir, Himachal Pradesh, parts of Uttarakhand. Which areas receive rainfall? Punjab, Haryana, Northern Rajasthan, Delhi, Uttar Pradesh, sometimes even Bihar, West Bengal, all the way till Assam. And although the total amount of winter rainfall locally, this rainfall in winter is referred to as Mahavat. So although that is small, they are of immense importance for the cultivation of Rabi crops like wheat and mustard. Okay, so this is the traveling western disturbance. As it travels all the way from the Mediterranean, brings rainfall over to India. That is observed during the winter months. So, in the months of December, if I ask you, in the months of December, which areas will receive rainfall? The significant regions of northeast, northwest, some portions of the northern plains, and significantly portion of Coromandel coastline. Some parts of even Maharashtra, Madhya Pradesh, or rather Rajasthan, and some parts of northern Madhya Pradesh also. But here the rainfall is caused because of western disturbance. Here rainfall is caused because of northeastern monsoon. Okay? And this is the average annual rainfall pattern in India. As you move, generally you will observe that across this region, western part of Western Ghats, orographic rainfall, northeastern part, orographic rainfall, Andaman Nicobar island region will receive heavy rainfall. So all these areas receive very high amount of rainfall. Leeward side of Western Ghats, limited rainfall. As you move away from the source of water, amount of rainfall reduces. So amount of rainfall reduces as one moves from south to north and from east to west. The amount of rainfall which is observed, that keeps on reducing. Okay? Now, taking a look at a couple of questions. Which of the following correctly describes the phenomena of western disturbance? They are aggravated monsoon winds blowing from west to east. They originate over the Mediterranean Sea and are carried to India by winds. Their effect can be felt mostly during the months of July to September. They can bring rains only over the hilly tract of Himachal Pradesh. This is an easy one. I hope you will get it correct. So a couple of questions. Western disturbance during April in Himachal, does it bring snow? Yes. This time it has brought the snowfall even in the month of May. So it can. And Sai Babu, why low pressure exists in western disturbance? Very good. Majority of you have given the correct answer. So Sai, the low pressure exists in the western disturbance because you have a frontal formation over the region of Mediterranean Sea. Because the air over the Mediterranean is warm, air coming from the European region is colder. So that is where you have development of a front. So you have a frontal cyclone, extratropical depression which develops. And that is where you have a low pressure. Rising air creates a low pressure. That is why. Pranay once explained monsoon trough with cyclonic rainfall. Okay. And Aarti, Somali jet stream and wind movement. Okay. So, Pranay, first of all, your query that monsoonal trough. Monsoonal trough is an isolated portion of extreme low pressure, right? Now, winds will rise here in a kind of a spiral manner. Now, this is a circulation of wind. So that is why this causes circulation, means a cyclonic circulation, because it is rising up. If it would be falling down in a spiral manner, anticyclonic. But it is rising up in a spiral manner, hence it creates cyclonic rainfall. Wherever you have trough, you have cyclonic rainfall which is created as a result of it. Okay? Is that understood? And Aarti, Somali jet stream and wind movement that time. Somali jet stream Aarti generally is observed again during the peak monsoon months of June and July, when you have significant amount of heating of the region of Somalia. So there you have a convectional rise of wind. Now this wind tries to move towards the ITCZ, and that is where it moves towards the ITCZ, crossing the region of the Arabian Sea. Now, this is not particularly moving at a level of tropopause. It is moving at a slightly lower elevation. So it carries, or it does the work of dragging the rest of the winds along with it as it reaches the Indian coastline. And why is it that it wants to reach the ITCZ if it is moving at higher elevation? Because that is where you have intense convection at ITCZ, both at the ground level as well as at a higher elevation. So the Somali jet's destination is the ITCZ. In the process, it is dragging rest of the winds to cover the region of Arabian Sea, and that is where it picks up more moisture, more rainfall in India. Is that understood, Aarti? Yes, if the Pranay, if you have a low pressure in isolated small area of low pressure, intense low pressure, winds will always rise up in a spiral manner. Now, consider the following statements about the phenomena of El Nino and its effect on Indian monsoon. It occurs in the region of South Pacific and hence has no impact on Indian monsoon. It leads to an increased rainfall over Indian subcontinent during the monsoon season. Its impact can be neutralized by Indian Ocean dipole and the Madden-Julian oscillations. Very good, guys. So here, first statement, it occurs in the region of South Pacific and hence has no impact on Indian monsoon. Incorrect. It reduces the rainfall received in India. It leads to increased rainfall over the Indian subcontinent. Incorrect. Its impact can be neutralized by IOD and MJO. That is correct. So the correct answer will be C. Pre-monsoon happens when wind reaches first the coastal area? No. Pre-monsoon happens much before this phenomena of wind reaching the Indian coastline. Pre-monsoon happens when you have heating of small areas, and because the summer season already starts. So from the late March itself, significant amount of heating is initiated. So that low pressure intensifies, it attracts the local winds, and that is where it causes pre-monsoon shower. Then, with reference to the retreating monsoons, consider the following statements. The Coromandel coast receives heavy rainfall as a result of this. It generally spans over a long duration from September to November. The movement of the winds is from southeast to northwest. Which of them are correct? How do we come to know that a low pressure zone brings convectional or cyclonic rainfall during monsoon? So, see, if it is a localized heating in general, it will bring about a kind of convectional rainfall due to evaporation. Cyclonic rainfall will bring rains for a prolonged duration, continuously for 2 to 3 days. It will continue to bring rain. Convectional generally lasts for half a day or so. Very good. So here, Roshan, which point you want me to repeat? So here, the first statement, Coromandel coast receives heavy rainfall as a result of this. Correct. It generally spans over a long duration from September to November. Correct. Movement of winds is from southeast to northwest. Incorrect. Movement of winds is northeast to southwest. So here, A is correct. Second question's points. Okay, this one. This is about the phenomena of El Nino and its effect. So El Nino, it occurs over the region of South Pacific, has an impact on Indian monsoon. Here it is saying no impact, so the first statement is incorrect. It leads to increased rainfall. El Nino reduces the amount of rainfall that is received. So this is going to be incorrect, right? So the third statement, its impact can be neutralized by Indian Ocean. So El Nino's impact can be neutralized by Indian Ocean dipole and MJO. So that is where it is correct. Okay? And that brings us to the end of Indian monsoon. Okay? Now, Dinesh, how is Western disturbance so strong to travel? Is it because of low pressure and the jet stream? Western disturbance is carried over by the westerlies and jet stream. The westerlies, the prevailing winds along with the jet stream. The jet stream ensures that it is a continuous low pressure maintained on the ground for a larger distance. And the westerlies, they carry the disturbance at a lower elevation. So both of them are responsible. Okay. So now we come to the portion of the climate classification. Here, we will talk about the global climatic distribution. You need a break right now, or should we continue? Do we need a break? Yes or no? Let me know. Okay. Okay, fair enough. Let me launch a poll then. So A, yes. B, no. No break. Okay. I give you 30 seconds to think about it. Meanwhile, this particular portion of climatic classification for your general studies is going to be relevant for your prelims only. Okay. Here we will study about Köppen's climatic classification. That is going to be relevant only for your prelims as far as GS is concerned. Yes, this is very tough in terms of that. Majority of us have asked for a break. Okay, we'll do one thing. We'll give a break. We'll have a break for 10 minutes and then we'll be back after 10 minutes. Okay? So, and then we'll continue up till 5. So let's take a break for 10 minutes and then we will be back. Okay? You need to wash up your faces in order to approach this topic. This topic is very theoretical. Generally, in many of the sessions, I would advise the candidates that after you have read the entire climatology, this is something you can cover on your own. But here we will be browsing through the portions, trying to ease it up for you. But nonetheless, it is going to be a tough task. We will take it up after the break. So let's take a break for 10 minutes and let's be back. A confirmation about the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. Utkarsh, I hope that this time the Köppen classification is not as torturous. So, but let's see. So here we will be talking about the global climatic classification, the different types of climates experienced across the globe, very much a part of, or you can classify it as world geography portion itself. Now here you will be reading about the different types of climatic conditions which are prevalent across the entirety of the planet, and different types of climatic conditions which are experienced in different seasons of the year. So here, not everything is going to be relevant or important for your examination perspective. It is very important to know what kind of questions will be asked, what kind of questions can be framed from this area. So from this area, generally you will find questions, for example, properties of equatorial climate, monsoon climate, savanna, then British type of climate, then Mediterranean type of climate, and also China type. Okay, just take a look at the basic properties of these climatic types, and that will be more than sufficient for your prelims examination. Here, basically, we'll be studying the Köppen's classification. So let me write it here itself. Codes, climatic codes need not be learnt. And here, when you are approaching this for your revision purposes, ideally, I would advise you that after you have had a very good grasp and grip over the region of, let's say, the pressure belt systems, the shifting of the pressure belts, the permanent wind systems, all those aspects, if you have understood carefully, only then approach this. Otherwise, it will be a theoretical exercise again. So we start with the climatic classification. Now, climatic classification across the globe has been one of those aspects which humans have always been inquisitive and curious about. Ever since man started discovering the various different places, they were very curious about the climatic conditions which are experienced in those places. Now, the very simplest form of classification was given by, at the time of the Greeks themselves, when they classified the entire climate and the distribution of the climate across the entirety of planet into three different zones. Now they classified it into three different zones. In the region of the tropics, they experienced very hot condition. So they thought that the tropics, they will be so very harsh, so very difficult that nobody can survive, nobody can live in that area. So that is why it was named as the torrid zone. Then beyond the tropics, they found that the conditions are much more pleasant, much more habitable. And that is where it was named as temperate zone. And then further north, the Greeks were able to explore that as you keep on moving northwards, you come across lands which are permanently frozen. So that is where they named this as the frigid zone. Frigid zone. Okay, So this was the earlier classification, and this prevailed for 1,000 years and more. Now, it was in the 1800s and late 1800s. By that point of time, botanists across the globe, and in fact paleontologists, botanists, geographers, geologists, they had traveled across the world, and you had very detailed findings of the various different plant types, animal types which are observed to be grown across the world. One of such compilation of the works of a famous French botanist was Candolle. Candolle was a botanist who compiled the entire work of the entire different types of plant species that you find in various regions of the world. Now, looking at that compilation, you had Vladimir Koppen, who basically wondered that what do plants require? Plants require adequate temperature, ideal temperature to grow. In different temperatures, different plants will grow, and also adequate amount of moisture. That is, if the moisture is variable in different parts, different types of plants will be observed to be grown. So, Vladimir Koppen, what he did was that based upon the vegetative growth, based upon the vegetative distribution, the natural distribution of vegetation, he basically started compiling the climatic classification. Right? So, Koppen's classification was based upon the classification of natural vegetation across the planet. Classification of the natural vegetation across the planet. Because Koppen had an idea that natural vegetation, it depends upon what? It depends upon basically temperature and rainfall or precipitation. And this, as per him, was the ideal definition of climate in a particular region. Now, that is why Koppen chose this method of classification. Later on, it was realized that plant growth in a region also depended upon, let's say, the wind factor. It also depended upon the rate of evaporation which is happening. So that is when later on, even Koppen's classification was modified by his pupils, and that was named as the Geiger-Pohl Koppen classification, and so on. You had other people giving in their own kind of climatic classification. You had classification given by Thorndike, you had classification given by Trebartha, but none of that is required to be studied for general studies. So that is the good news, right? So for general studies, you all need to know just the basics of Koppen classification. Now, when we talk about the basics of Koppen classification, here, what Koppen did was he used alphabets to designate different types of climatic conditions. And what alphabets? He used capital letter alphabets. So he started using, for example, A, B, C, D, E. These were the major alphabets. Now, he used A to describe equatorial climate, tropical and equatorial. Now, what is tropical and equatorial? Average annual temperature is higher, right? Rainfall is also received at some or the other part of the year. So, generally observed across the region of equator. Then as you move away from equator, you come across the subtropical high pressure belt. Subtropical high pressure belt is around the region of 30 degrees. What is the temperature in that area? The temperature is high or low? What do you think in the subtropical high pressure belt? Let me know. Good. Temperature is high because it is in the tropics, right? The subtropical high pressure belt, the temperature is generally higher. and there is no rainfall at all because it is a high pressure, it is a region of sinking air. So you have sinking air means no rainfall, and you have high temperature as well. So what kind of conditions will you observe there? You will observe desert formation. So that is where he used B to indicate deserts. Generally arid and semi-arid areas. Then further away from equator that you go, even away from the subtropical high pressure, which portion do you come across? You come across the region which is frequented by westerlies. So you have either summer rains or you have winter rains, or sometimes you have rainfall throughout the year, especially across the coastal area. That is what he named as C. That is temperate climate. Right? Temperate region, around 50 degree, 40 degree and above, in that area, 40 degree north and south latitude and above that. So that is where you have temperate climate, in the sense that winters are not very harsh, winters not very cold, and summers not very warm. Then furthermore, away from the equator that you go, around the region, let's say northern part of Canada, around the region of Siberia, the conditions are particularly cold, very cold, isn't it? So that is where he came across the D type, that is subpolar, cold climate. And then furthermore, the polar climate, he indicated it as E type. So these were basically the classification, or these were the alphabets used to designate the entire planet's climatic classification. But he also came across something unique. He found out that basically when we talk about any particular region, any particular area, now that area, it does not only depend upon the latitudinal extent, the temperature is driven also by altitude. For example, we have taken the case of Agra and Darjeeling. At the same altitude, they indicate, at the same latitude, they indicate very different temperature. Similar is the case, let's say, around Ooty and let's say any place in the southern coastal area or southern plains, you will experience that Ooty, being situated at an elevation, experiences a lower temperature. So in all these highlands or in all these elevated regions, you experience lower temperature owing to the altitude. And that is where he used the letter H. H was used to indicate highland type of climate. Type of climate. This indicates regions situated at an altitude. Okay, so this was the broader classification overall if you take a look at it. A type, humid tropical climate, warm and moist condition, average annual temperature greater than 18 degrees Celsius, and the mean temperature always above 18 degrees Celsius. Moist conditions mean availability of rainfall, availability of precipitation. B type, dry climate, moisture deficit. Moisture deficit. So you have desert conditions. Desert conditions. Then C type, temperate type, around 40 degree to 60 degree, right? Mid latitude area beyond the subtropics. So that is where the winters are not very cold, summers are not very harsh. So you have temperate type, moderate type climate, mild winters. Average temperature of the coldest months basically are around 8 to 18, and in the warmest months around 18 to 22 degrees Celsius. So that is where you have a most tolerable kind of climatic condition, if you can think about it in that way. D type, the region of Siberia, the region of Canada. Now, average temperature of coldest and warmest months below -3, -5, -10. Sometimes even the warmest months will be around 5 degrees Celsius, 7 degrees Celsius, like that. And E type, polar climate characterized by summerless season. Now, if you take a look at this kind of delineation, obviously, you don't get an idea about the amount of rainfall. You get an idea about the temperature aspect. But at the same latitude, different areas can experience different rainfall as well. So, in order to categorize the amount of rainfall and also the degree of temperature, that if I say equatorial areas or tropical areas, not all the tropical areas will indicate the same temperature. Some areas will be very heated up, some areas will be slightly cooler. Same is the case with the temperate region as well. So, in order to indicate the rainfall characteristic, that when a place does receive rainfall, he used the small letters F, W, M, and S. Okay, F, no dry season, right? Remember it as full rainfall or rainfall for the entire year. So, F means complete rainfall or full rainfall throughout the year. So, no dry season. Every day, every month, it continues to rain. Then you have M, that is monsoonal climate. Then you have W. W means winter is dry. That means rainfall is received in the summer, but winter is a long dry spell. And S means summer is dry. No rainfall in summer. Rainfall will occur only in the case of winter. Then even the degrees of heat, A, B, C, and D, were used to denote the degrees of heat. So based upon all these, you had codation or coding which was done for the different climate types. For example, A type was further divided into AF, AM, and AW. C type, for example, would be divided into CFA, CFB, CS, and so on. CW even. Similar is the case with D type, B type as well, right? So that is how codes were developed for the various different climatic types. This is the classification and the pattern of climatic distribution observed overall. Here you will come across a situation that basically how to learn it, how to remember it. So generally always understand, if let's say this is the region of equator, closest to the equator you have the A type. As we move further away around the subtropics, we come across the B type, the desert areas. Then you have the temperate areas, that is the C type, the C type. Then D type, and then eventually E type. So that is the progression away from equator as you move to the poles. So now let us start with the aspect of each one of them one by one. Let us take a look at the different types of climate. Now here, I would advise you, restrict yourself, limit yourself to the PPT itself in order to cover this or in order to read this particular portion, and that will be more than sufficient for your examination requirement. So starting with the group A or A type of climatic condition. Now when we say the A type of climatic condition, it is a tropical humid. Humid means there is availability of moisture. Tropical means it is present in the tropical region. So the average annual temperature is going to be higher than 18 degrees Celsius. So here they exist between the Tropic of Cancer and the Tropic of Capricorn. The sun being overhead throughout the year in some region or the other makes the ITCZ, or the presence of ITCZ makes the climate hot and humid. So if the ITCZ is present, ITCZ is a region of low pressure, And in the region of ITCZ, we receive rains. Rains. So that means humid climate. Now, annual range of temperature is very low. Means what? The variation of temperature in between the various seasons, that is never very high. That means the summer temperature and the winter temperature, they are very close to each other, right? So annual range of temperature is very low and the amount of rainfall annually is very high. Now this is further divided into AF, AM and AW. Let us take a look at each one of them. Let us try to understand their features. Now starting with AF, F indicates rainfall throughout the year, no dry season. So rainfall throughout the year on a daily basis, observed generally across equatorial regions. So observe at Iquitos in Peru. This is the weather data of Iquitos in Peru, equatorial region. So here you will observe the temperature. Observe the temperature. The red line indicates the temperature. So the temperature is largely consistent between 25 to 30 degrees. So observe annual range of temperature is minimal. The amount of rainfall received is prevalent throughout the year. Every month you have rainfall which is received. Every month. January, February, March, April, May, June, July, August, September, October, November, December. Every month you will receive some or the other amount of rainfall in this region. That is the case with equatorial region. What kind of rainfall is received in equatorial area? Which category of rainfall, if you have to finalize or if you have to basically think about the type of rainfall? Very good. In equatorial areas, you always end up receiving convectional rainfall, daily evening showers. So here you will receive lot of convectional rainfall. Rains in evening. Okay. So here if you take a look at it, precipitation is common year round and variation in temperature in between the various seasons is less than 3 degrees Celsius. So the temperature is consistent. Humidity is extremely high. Why? Because the surface temperature results in formation of cumulus and cumulonimbus clouds in the early afternoon, and this causes rainfall on a daily basis. This is a convectional rainfall. So here what you will come across is the fact that you have very dense vegetation, significantly dense amount of vegetation. The trees, they will be particularly very tall. Here you have evergreen kind of vegetation. What is evergreen? Some or the other part of forest always gives you that green coloration. Not all the trees will shed their leaves at the same time. If let's say few pockets of trees, they will shed their leaves, the others will then regrow their leaves during that point of time. So every time the forest will give you an appearance of greenliness. That is why evergreen. Now moisture is one of the requirements of the growth of the trees. Now in this case, moisture is perpetually available. So they don't have to worry about moisture. Here, trees compete for sunlight, and that is why they grow very tall, right? So trees compete for sunlight. Hence, very tall trees. Right? And also, they will be very dense. The canopy will be very dense. What is a canopy? For any tree, if you talk about it, any tree's structure will be somewhat like this. So this portion is referred to as the canopy. So the canopy will be very dense, very thick. In this area, you will come across species which are generally not very large, but arboreal species. For example, different types of apes, monkeys, chimpanzees. You will find them in that region. You'll find a lot of birds, a lot of reptiles, and significant amount of frogs, etc. That is something. Insects in very large proportion is also something you'll find in this region. So tropical evergreen forest with dense canopy cover and large biodiversity observed across the equatorial regions in Peru, Amazon forest, Congo River Basin in the region of Africa, Philippines, parts of Indonesia, and so on. So that is where you find the distribution. It is here in South America, here, this tropical evergreen forest, they are known by the name selvas. So observe here that in the region of Peru, in the region, some parts of Venezuela, some parts of Brazil, some parts of Congo Basin, and Southeast Asia in general, including some parts of Andaman Nicobar Island, you'll find this type of forest. Okay? Then you have the characteristic of AM. AM means monsoon climate. Monsoon climate, what do we know? That maximum amount of rainfall is restricted in very few months. 3 to 4 months, huge amount of rainfall. Rest of the year, little amount of rainfall. Example, Mangalore in India. Now here observe the amount of rainfall is very, very heavy during these months of monsoonal rains, right? So the amount of rainfall in 1 month, if you have to think about it, in 1 month, this region receives around 1,000 or 100 centimeter of rainfall. Look at the equatorial region. In 1 month, how much rainfall they receive? At max, 250 to 300 millimeter or 25 to 30 centimeter. So in 1 month itself, the monsoonal region receives very high amount of rainfall. But all that rainfall, heavy rainfall, is restricted to 3 to 4 months only. Then the amount of rainfall reduces. So here, annual rainfall is overall similar to that of AF type, but precipitation occurs within the 7 to 9 of the warmest months of the year, generally after heating. That is where the low pressure comes over that region, and that is where you have the AM type. During the rest of the year, there is less precipitation. Winter is generally drier. Found over the Indian subcontinent, northeastern parts of South America, and northern Australia. Heavy rainfall occurs mostly in summer. Here you will find monsoonal forests in existence. What are monsoonal forests? These are the deciduous forests. Deciduous means they will shed their leaves at the same time. In order to survive during the dry season, the trees will shed their leaves. So as the trees will shed their leaves, why? Because when water is scarce, they cannot have the loss of water through their leaves being carried on. So during the dry season, they shed their leaves. And again, when the rains come in, they will thrive in terms of the availability of greenliness. That is what is deciduous forest or deciduous trees. So overall, observed in portions of India, some portions of also in Southeast Asia, all around the AF type to the extremities of AF, you will experience AM. Then after that, you have the savanna. Savanna basically is AW. Now, AW, basically here you will observe that just by the image you will observe, there are larger areas of grasses, very large grasslands. Okay, you'll find these are what are referred to as tropical grasslands. Now, why grasslands? Why not trees? Trees are very restricted here because the dry season is very prolonged. You don't have significant amount of rainfall. The rainy season is restricted to 2 to 3 months of the year. And that prolonged dry season means only grasses will grow whenever the rains are there. And also, in this region, you will find very large animals. For example, the larger herbivores. For example, elephants. All of them you'll find here. Now, that is where even if, let's say, a small plant or anything starts to grow, a small sapling starts to grow, they are immediately consumed. So that is why generally you will find a lack of tree cover. Trees are very less. Now, during the drier season, At the end of it, all the grasses, they become very dry, and obviously the grasses, dried grasses, they catch fire very easily. So even if a stray incident of lightning, an isolated incident of lightning occurs, the entire grassland can immediately burn up. So here, wildfires and forest fires are very common. Are very common. Okay, that is AW. So AW overall, observe that rainfall is restricted and then you have a dry spell. So this is observed in various parts of the world, and here you have various tropical grasslands. You can observe in India also you have these grasslands. In Africa you have a lot of this grassland. This region in Africa, this is also referred to as the Sahel region. Sahel region. Then this area, you have Campos and Llanos in Venezuela and Brazil, the grassland region. So these are very extensive grasslands in existence. So here, the wet season is shorter and the dry season is longer, with the drought being very severe. Absolute lack of water. Temperature is high throughout the year, and the diurnal ranges, that is the daily variation. Diurnal range means the daily variation in terms of temperature, are the greatest in the dry season. Why is it that the daily variation of temperature is greatest in the dry season? Air is dry, means dry lapse rate, which means loss of heat is very quick, is very fast, which means night temperature is low. Is very low. So daytime temperature is very high during the dry season. Nighttime temperature is significantly lower. Tall to continuous grasslands with scattered trees and deciduous forest. Very little amount of deciduous forest is to be found. To be found in northern and eastern India, parts of Burma, Llanos of Venezuela, Campos of Brazil. These are your famous grassland regions. Sahel region in Africa. These are your famous grassland areas. Okay. Then we come across the B type, which is the dry climate, generally arid and semi-arid conditions. Now here, Köppen used another set of alphabets. So if you were thinking that the alphabets, all the various alphabets that we had seen, if that is enough, that is not enough. Köppen here used another set of alphabets. Basically, he used other set of alphabets in the sense W and S. Capital W and capital S. W represented dry desert and S represented semi-arid steppes or some types of grasses in the temperate region. Then he used the small letter H and the small letter K as well. Average temperature higher than 18 degrees Celsius. K, when you have average temperature lesser than 18 degrees Celsius. So that is where he used this for BWH, meaning hot dry desert. BWK, meaning cold desert. Similarly, BSH and BSK was also used. So B type of climate generally are characterized by very low rainfall, that is not at all adequate for the growth of plant life. So here you have very unique kind of vegetation which grows in these desertified areas, and that vegetation is referred to as a xerophyte. That is a vegetation type which is referred to as xerophyte. So the various species of plants and animals, they adapt according to the conditions that you observe here. Very large diurnal temperature range, highest daytime temperature overall is experienced and is observed here, right? Large diurnal range means the difference in temperature between the day and night, that is very high, because here also the air will be dry, so the loss of heat will be very quick. So that is why the nighttime temperature will be very low. Evaporation and transpiration, they play a very greater role in shaping up the plant or the vegetation life, because even if, let's say, it rains, immediately everything evaporates. So this is a region which is moisture deficit in general. So here, take a look at it. BWH, BWK, they indicate hot and cold desert. For example, the Atacama Desert here, a cold desert. Then Sahara Desert, a hot desert. Victoria Desert, a hot desert. Then here you have Rubal Khali, that is a hot desert. You have Daste Lut and Daste Kavir, hot desert. Here you have Gobi Desert, which is a cold desert. So that is where in all these areas you will find desertified locations, because of the fact that either they come across high pressure region, so no rainfall, or here these basically are in the inland areas where moisture is not carried at all. That is why these are desert. Diurnal temperature means the difference between the daytime and the nighttime temperature, Sai Babu. So when we talk about diurnal temperature, so diurnal temperature range means variation in daytime and night time temperature. So if the range is high, if there's a large range between the daytime and the nighttime temperature, that means what? The daytime temperature is very high, nighttime temperature is very low. So starting with the desert, that is BW type of climate, you will observe that it covers close to around 12% of the Earth's total land. These are deserts, actual proper deserts, the ones that you see in the movies where you have sand and sand dunes for larger stretches, and in the movies you will also find the actors and the actresses dancing upon it, so that is a different matter altogether. But those kinds of deserts, that is BW. Now here, xerophytic vegetation, usually they grow in this climatic condition. Letter H and K, they are used as suffix to indicate whether it is hot or cold desert. So hot desert, where the average temperature is above 18 degrees Celsius, H is used. Average temperature above, higher than 18 degrees Celsius. Cold, K is used. Average temperature lesser than 18 degrees Celsius. Okay, that is basically used in order to designate BW, right? Typical BW climate that you will observe, BWH, a hot desert climate that you will observe in the region of Algeria. Observe that the temperature spikes up during the summer and the rainfall or the precipitation is almost absent. So that is why daytime temperature is very high, nighttime temperature very low, because the loss of heat is very quick. Then we have BS, semi-arid, or a steppe type. Here you will find the presence of grasses, small grasses, not very large, but presence of some grasses. So it spans about 14% of the earth and makes up the grassland type. Now here you will receive some amount of rainfall, but the rainfall is generally caused due to mid-latitude cyclones. Right, frontal formation is observed. So here you will observe frontal formation. frontal formation, some rainfall. Okay. Now here also B, S, H and K is used. H represents a hotter condition. Take the case of Australia. You will observe that during the winter conditions in Australia, the rainfall is very limited. Summer, some amount of rainfall, leading to the presence of grasses, right? So here, that is basically the aspect of grasses. Now, this is again divided. For example, when we talk about mid-latitude desert and steppe, that is BSK and BWK. Now, these areas, they receive little rainfall. So the climates are dry because of extreme continentality, means very far away from the coastline. Very far away from the coastline means availability of moisture in the winds is very limited, very, very less. So that is why extreme continentality means the winds are unable to bring moisture. Why is it that India's landmass is so unique? Because there is always availability of moisture from the nearby regions, and you have the impact of high elevations in many areas. So being located in the center of the continent limits the amount of moisture supplied from ocean sources. Without this moisture, precipitation cannot occur. Presence of mountains upwind of this climate further reduces the moisture availability because of rain shadow effect. So for example, take the case of Gobi Desert. Now, Gobi Desert, for example, if you take a location of it, this region, so here you have all the various different mountain systems. Kudlun Shan, Altai Shan, Tien Shan, all these, right? Hindu Kush, Himalayas, Karakoram. So there is no way that moisture will be able to reach the region of Gobi. That is why it is a desertified area, and situated in a higher latitude means a cold desert. Major expanses of mid-latitude deserts can be found from the region around Caspian Sea, north of Himalayas, even the Xinjiang region, western part of China. That also falls into some amount of cold desert. Western US, east of Andes, that is around the region of South America, you have the Atacama Desert. Mid-latitude deserts have a greater range of both daily and annual temperature as compared to the subtropical counterparts. So this is basically very limited amount of rainfall which is available. Temperatures soar through the roof. Then we have the temperate type of climate. That is the moderate. The winters are not very harsh. Summers are not very harsh either. Now here, generally, you will observe the climate to be conducive enough to grow various different types of fruits. So a lot of these areas, they are specialized in the growth of fruits. So here, C type is further subclassified. If you take a look at it, it is further subclassified into various different types. So hot and humid summers and milder winters, generally between 30 to 50-degree latitude northwards and southwards from equator, right? The middle latitudes in general. And here they are typically situated at the eastern or the western coastline of the continents. So here rainfall is received either because of consistent movement of onshore winds, or due to shifting of the pressure belts. Sometimes the westerlies become onshore, sometimes they become offshore. So onshore and offshore phenomena here causes significant rainfall. So along with the mid-latitude cyclones, obviously. So rains in this region are caused either because of onshore and offshore winds, or because of shifting of the pressure belts, and sometimes even due to frontal formation. Okay, so it's various types and categories if you take a look at it. So this is the C type of climate. Observe further away from the region of equator. So here, even in this area, you will observe C type of climate. In the region of Britain, in the region of western part of Europe also, you will experience C type of climate. Around the Mediterranean Sea, you will also observe sea type of climate. So these are the regions where you experience sea type of climate. This is subdivided. If you take a look into CFA, humid subtropical, CFB, marine west coast. This is what is referred to as British type of climate. British type of climate. CS, or the Mediterranean climatic zone, and CW, that is the China type of climate. Now, if I ask you just by looking at the codes, British type, Mediterranean type, or China type, which will receive the highest rainfall in terms of throughout the year? Which will receive the highest rainfall? British type, Mediterranean type, or China type? Good. British type, because it is F. F means rainfall throughout the year, right? So that is why every day almost, in fact every week, every month, you do receive rainfall in the region of Britain. Why? Because that is a region of westerlies. Westerlies come over to that area, and westerlies overall, they will flock that area, they will be onshore, and they will bring a lot of rains. Okay? Now, after that, one by one, let us take a look at it. So CFA is a humid subtropical climate. Now it lies on the eastern part of the continent in subtropical latitude. Now there you have no dry season. Why? Because the air masses are unstable, they cause rainfall. In many of the cases, it is the trade winds which become onshore in that area sometimes to cause rainfall, sometimes. Now, examples are eastern part of United States, southern and eastern China, southern Japan, northeastern Argentina, and so on. Annual range of precipitation is between 75 to 150 centimeter on an annual basis every year. This is the case of CFA. So here you will observe that rainfall is observed all throughout the year. The temperature peaks. This is Memphis, Tennessee in United States. The temperature peaks during the summer, but it is not very high. Even the peak temperature is around 26, 27 degrees Celsius. And winters, again, not very cold, around 6, 7, 8 degrees Celsius. That will be the winter condition. So rainfall throughout the year. Okay. Now, after that, here, this is the CFA type generally observed here. This is the region of CFA type, some portions of here. These are the areas of CFA type. Okay. Now, then we have CFB, or marine west coast climate. Now, CFB, also referred to as the British climate. Now, here you have daily occurrence of rainfall because of onshore movement of the westerlies. And here also, the temperature conditions are moderate throughout the year. There is no extremity of climatic condition. It is not going to become very cold. It is not going to become very hot. Why? Influence of the marine conditions. Just like in the coastal regions of India, we don't have any extremity of temperature. We have moderation of temperature. A very similar phenomena is observed in this region as well. So located poleward from the Mediterranean climate on the west coast of the continents. Now here the temperature is moderate because of the marine influence, and in winter, because it is moderate, along the same latitudes, you will observe much harsher winter as compared to these areas because of moderation. Winters are milder. They come with heavy rainfall due to mid-latitude cyclones. So that is British type. Marine west coast, British type. Observe London, England. Right? So rainfall throughout the year. Rainfall is observed throughout the year. Okay? Now, then after that, you have, are mid-latitude and temperate cyclones the same? Dinesh, yes. This is the CFB. Here you have the westerlies, which become onshore, which creates rainfall. Okay? That is basically the British type. Then after that, we have the CS, or the Mediterranean type of climate. Now, Mediterranean type of climate obviously will be observed around the region of the Mediterranean Sea. Now here, you will come across the fact that CS, summers are dry. So summers are dry. Why? Summers dry. Why? Because this is the region which comes under the influence of subtropical high pressure in the summer season. Right? Now, during the winter season, all the pressure belts will shift slightly to the south. So, as the pressure belts, if you can imagine, if you can take a look at the image here, so during the summer, this region will be the high pressure, so no rainfall. But during the winter, as the pressure belts, they will shift to the south, this region will experience westerlies. So they will carry up the moisture from the Mediterranean, they will drop it across the coastline of Mediterranean, bringing rainfall only during winter. And also, while studying the portion of western disturbance, we have also seen about the fact that difference in temperature between the Mediterranean Sea as well as between the European landmass gives rise to many temperate cyclones which develop in that area. So westerly winds during the winter is observed due to shifting of pressure belts, due to shift of pressure belts. And the shift of the pressure zone. Okay, precipitation ranges between 35 to 90 centimeter. Precipitation is heaviest during the winters due to mid-latitude cyclones which also develop. Hardly any rainfall during the summer. Temperature in summer is around 25 degrees Celsius. In winter, it is below 10 degrees Celsius. Generally here, you will observe the growth of fruits. So fruits are grown in large quantities. Generally, you will come across growth of fruits and fruit orchards that will be observed in large quantities. Then after that, we have the CW, or what is also the China type of climate. Now here, W means winter is dry. So summer has rainfall. So why will the summer experience rainfall? That is because during the summer season, it is dry in winter. During the summer season, because of hot conditions, ITCZ tends to lie over the region. As the ITCZ tends to lie over the region, it brings about rains, convectional rains in significant amount during summer. Okay, that is basically CW, or humid subtropical. Then we come across the continental areas at higher latitude, that is beyond the C type, in the subpolar region. As you move into the region of Siberia, as you move into the interior of Russia, into Canada, now that is D type, or what is referred to as the cold snow forest in general. Now this cold snow forest, again, you can have the region on a coastline. If you have a region on a coastline, obviously the rainfall will be available throughout the year, right? You have the westerlies also available at this latitude. So coastal areas will receive rainfall throughout the year, but interior areas, they don't receive rainfall throughout the year. So these are the regions generally you will observe in the D type. But observe, there is no such D type in the southern hemisphere. What do you think might be the reason? Here, the only place where the D type can exist is this place, southern part of South America. Now, that southern part of South America, That is also what is referred to as the Patagonia Plateau. That is surrounded by water bodies in very close proximity. So it generally has got a marine influence. Hence, it does not have the D type. D type is restricted here, Canada, Alaska, Siberia, parts of Europe. Okay. Now, overall, if you observe, these occur in large continental areas in the northern hemisphere between 40 to 70-degree latitude in Europe, Asia, and North America. Summers are typically warm, but can also be cool, while winters are cold. Very low temperature, -5, -10 degrees Celsius. During the summers, the average temperature can climb over around 10, but during the winters, it is less than -3 degrees Celsius, anything. So here also classification DF, DW, DS, depending upon when you receive rainfall. You can remember these codes if need be, but it is not required for your examination. If you take a look at the past pattern of UPSC, UPSC has never asked the codes that DF is found where or DS is found where. Now, if your luck is so very good that the time that you are appearing for the examination, there only UPSC asks it. So always have that method. F, think about it, F means full rainfall throughout the year. So F means no dry season. W, winter dry. W stands for winter, winter dry. M stands for monsoon. So rainfall only during those particular monsoonal months. S stands for summer, so summer dry. So that is how you can basically try to get some grip around that F, W, S, and M. Now, severity of winter obviously will be much more pronounced at a higher latitude. Now, when we say DF, cold climate with humid winter, occurs poleward of the British type, right? Winters are cold and snowy. So why DF? So these are influenced by the onshore winds. So northwards of marine west coast, so also situated on the western coastline, right? So there will be influence of westerlies even in this area in many of the regions. Frost-free season is very short. That is, the ice-free region is very short. Majority of the months covered in ice. Annual range of temperatures are large, means winters are very cold, whereas when we talk about summers are moderate. Okay, then after that, take the example of this Winnipeg in Canada. So if you observe the summer and the winter temperature, observe the winter temperature first. If you were to observe the winter temperature, observe it is around -20 degrees Celsius. Summer temperature can be around 20 degrees Celsius. So annual range of temperature, 40 degrees Celsius is the annual range of temperature. Right? So that is basically the DF type. Then you have, after this, you have the DW. DW means winter is dry. So cold climate with dry winters, mainly over the northeastern portion of Asia, around Kamchatka, around the region of Vladivostok, or around the region of Siberia. Development of a pronounced winter anticyclone means high pressure due to very cold conditions. High pressure due to very cold conditions. Okay, and its weakening in summer sets up the reversal of wind direction. That is why during the summer, as this high pressure weakens, some amount of rainfall is still received due to the development of a kind of a front in that region. So some rainfall is received in summer, but winter is dry. Precipitation occurs in summer. You have the development of front in that region. Annual precipitation observed 12 to 15 centimeter only. Now, in that much amount of rainfall, if that little amount of rainfall would have happened in India, it would have been nothing but the Thar desert. But here, you will still find forests. Why? Why do you think that at this region, At 12 to 15 centimeter, you can have forest, conifers, but in India, you will have desert conditions. That is because it is in this area that you will come across very limited evaporation. Evaporation is extremely limited. That is why even this much amount of moisture is oftentimes deemed to be more than sufficient. Then, when we come to polar climate, the E type. So here again, for example, the coastal areas of Greenland, they will have different moderate type of climate, but the interior areas of Greenland, the region of Antarctica, they have extreme permafrost type of climate. Permafrost means permanently frozen. So E type is divided into two categories, EF and ET, right? So polar climates exist polewards beyond 70-degree latitude. Temperatures are usually low all year round in the polar climate regions. Warmest months overall, there also the temperature is less than 10 degrees Celsius. In the case of EF, that is less than 0 degree itself. Usually occurring in the north coastal region of North America, northern part of North America, northern part of Asia and Europe, also in Greenland and Antarctica. That is where you have the polar landmass. It is divided into two types, ET and EF. ET still will have tundra, that is mosses and lichens. So sometimes the topsoil can be rid of ice, but the subsoil is always permanently frozen. During summer, tundra regions have very long duration of daylight. Why? Because of the tilt of the planet on its axis. That is why, remember, in the first module itself, we had studied that the polar regions, Arctic, Antarctic region, they can experience up to 6 months or 4 to 6 months of continued daytime, 4 to 6 months of continued nighttime as well. Mosses and lichens can grow in this region. After that, this is the region of ET, coastal areas of Greenland, northern parts of North America. And then the interior portions, they will be EF. Now observe, even the driest or the summer months, overall the summer months, what is the temperature? Just barely above zero. And what is the winter temperature? Minus 30 degrees Celsius and beyond. So that is the coastal areas. Imagine what will be the condition in the interior landscape. So then you have the EF. EF is permanently frozen or ice cap. So surface is permanently covered in ice and snow. The ice cap or EF occurs in interior portion of Greenland and Antarctica. No growth. Temperature is permanently below freezing point. Area receives almost negligible precipitation or little to no rainfall at all. So here the temperatures can be particularly low, minus 35, minus 40, minus 45. That can be the temperature even during the summer. Minus 5, minus 10 is the temperature. So this is basically the climatic classification of the entirety of the planet, or the world climatic classification. Now, if you take a look at the map, now you will be able to compile it in a better way, in the sense that closer to equator, you have the A type. As you move slightly beyond the equator, you have the B type, the desert region. Then you move slightly in the mid latitudes, coastal areas, C type, moderate temperate type of climate. Then interior areas of Canada, regions of Siberia, Alaska, D type, cold snow forest, and then polar region, E type. Okay? Now, here a couple of questions is what we will deal with. So, the seasonal reversal of winds is the typical characteristic of which of this climatic condition? Seasonal reversal of winds. I hope we are still active, alive, and kicking. Okay, very good. Seasonal reversal of winds, monsoon climate. That is where after every season that varies. Now here this is 1, this is 2. Consider the following statements. The winds which blow between 30° north and 60° south latitude throughout the year are known as westerlies. The moist air masses that cause winter rains in northwestern region of India are part of westerlies. Which of the statements given above is or are correct? Read the option statement carefully, guys. Very good. So, the first statement, winds that blow between 30° north and 60° south latitude throughout the year are known as westerlies. This is incorrect because there is no wind from 30° north to 60° south. It is either from 30° north, 60° north or 30° south, 60° south. This is where UPSC plays with the concentration level of the candidates. That is the only temperamental work that you have to do upon you. That whether you are able to concentrate about these tricks and various different types of mischiefs that UPSC has upon its sleeve. Moisture masses that cause winter rains in northwestern region of India, winter rains are brought by the westerlies, so that is correct. So you have 2 only. Then after that, which one of the following is the characteristic climate of the tropical savanna region? Rainfall throughout the year, rainfall in winter only, an extremely short dry season, a definite dry and wet season. Think about it. The code, I will give you the hint. The code for tropical savanna is AW. Very good. So that is a definite dry and wet season. So rainfall throughout the year, not present. Rainfall in winter only, no, you have winter dry here. Extremely short dry season, no, you have a very prolonged dry season, and definite dry and wet season. Then consider the following statements. The duration of monsoon decreases from southern India to northern India. The amount of annual rainfall in the northern plains of India decreases from east to west. Which of the statements given above is or are correct? Dinesh, the western disturbances are carried by the westerlies. So that is why the second statement will be correct. Very good. So duration of monsoon decreases from southern India to northern India? Correct, because monsoon reaches the northern India last and withdraws from there first. So in southern India, it is present for a longer duration. Amount of annual rainfall in the northern plains of India decreases from east to west because you move away from the source of moisture, that is the Bay of Bengal. So that is also true. So you have C, both 1 and 2 are correct. During a thunderstorm, the thunder in the skies is produced by meeting of cumulonimbus clouds in the sky, lightning that separates the nimbus clouds, violent upward movement of air and water particles. Which of these produces thunderstorm? Or thunder is produced by which of them? So all these PYQs and the portions we have discussed very distinctly and in greater detail. So even if you manage to recall, let's say, around 70-80% of it, you'll be in a very good place in the prelims and the mains exam. How many of you marked an answer here just because you thought that some of that has to be correct? How many of you marked 1 and 1 and 2 only, etc., just because you thought that some of this has to be correct? So that is why have some self-confidence. Why is it that a thunder is produced? Thunder is produced due to, we have discussed about it, sudden violent expansion of air. As the lightning event happens, the air in that region heats up and there is a sudden violent expansion that produces thunder. None of the option statements mentioned here, they talk about that. So the answer will be D. And this is what will happen in the prelims examination. Many of us, we think that look at the detailing of the option statement. There is no way that UPSC would have done this to create none of the above as the answer. Lightning that separates the nimbus clouds. If that is the case, then thunder would only be restricted only in certain nimbus clouds. And you wouldn't have any thunder between the cloud and the ground, right? Meeting of cumulonimbus clouds in the sky. So that means any individual cumulonimbus cloud won't observe a thunder. They would. So first and two are incorrect. 1 and 2 are incorrect. All the options are incorrect. Right? So have some confidence that it is not going to be absolutely worst when you look at it. Seasonal reversal of winds is the typical characteristic of monsoon climate, a question which was repeated. Now, again, another question from climatic classification. Read the option statement carefully and then mark the answer. I will give you 1 minute time for this. Yes, Benita, correct. Correct, Vivek. Good. So each day is more or less the same. That means a similarity of weather conditions throughout the year. Morning is clear and bright with a sea breeze, right? As the sun climbs high in the sky, heat mounts up, dark clouds form, and then rain comes with thunder and lightning, means a daily convectional rainfall. But rain is soon over. That is equatorial. So that is where you have daily occurrence of rainfall. Okay? Why are dewdrops not formed on a cloudy night? Why are dewdrops not formed on a cloudy night? Clouds absorb the radiation released from the Earth's surface. Clouds reflect back the Earth's radiation. The Earth's surface would have low temperature on cloudy nights. Clouds deflect the blowing wind to the ground level. Why are dewdrops not formed on a cloudy night? So many of you have marked C. That means the concept is lacking quite significantly in that portion. See, whenever you have cloudy nights, the conditions of cloud cover, whenever you have cloudy conditions, now the terrestrial radiation which is lost, that terrestrial radiation is re-radiated back, reflected back by the cloud cover. So what it does is, it heats up the surface again. Surface gets heated. That is why always remember what I have reiterated continuously. Cloudy nights are warmer as compared to the clear sky. Because when you have a clear sky, heat is lost in a very straightforward fashion. Clouds, they will absorb and will re-radiate it back. And for the dew formation, you need the loss of heat. So that is why B is the correct answer, that during the cloudy nights, the clouds reflect back the Earth's radiation, due to which there is a significant amount of heating and cooling is required for dew formation. So that is why no dew formation on a cloudy night. Okay? That will mark the end of the portion of climatology overall. And now we enter into the portion of oceanography. Okay, so now we enter into oceanography. Here we start the discussion with the various different portions of oceanography that we are going to cover in that entire duration. So basically, oceanography is nothing but the study of oceans overall. That is what is oceanography. Now here we shall be studying the various aspects with regards to the bottom relief of the ocean temperature that you have, ocean salinity that you have, waves, tides, ocean current, everything will be covered here. So that is why now this is one of the low hanging fruits for your examination. Here the questions that you will get will be very direct, just like in the case of in the case of geomorphology. UPSC doesn't have much scope to twist the type of questions that you get asked in this area. So very simple, straightforward questions. You cannot afford to do your mistakes here, because your competition will never commit mistakes in these easy questions. Your competition is not that individual who commits mistake in all type of questions. Your competition is that individual who has prepared for the mains examination, who is very well prepared and ready for the mains. So that is something you have to keep in mind. Now here, what is relevant for your prelims overall? Basically, features or factors of ocean temperature, factors of ocean salinity, then aspects such as tides, then ocean currents. Okay, these are relevant for your prelims examination. In the mains examination, the important portion is thermohaline circulation, ocean currents, right? These are especially the case of North Atlantic, and also especially the case of North Indian Ocean. Factors influencing, even this year, that is in 2022, you had a direct question asked from this. Factors influencing ocean current. Okay, these are going to be relevant for your examination. So we'll start first of all, just like how we started in the rest of the portions as well. We'll start with the very basics. That is the ocean bottom relief. And slowly and steadily, we will move ahead. So when we talk about oceans in general, here, understand, whenever we talk about the oceans in general, ocean relief means what? The topography that you observe in the case of various oceans, that is what is referred to as ocean relief in general. So ocean relief basically refers or indicates to you the bottom relief features of the ocean. So when you take a look at the oceans, we get an idea, we get an understanding that the ocean bottom is not plain, not smooth. Okay, it has got various indentures and various features which dot the entire region. Okay, so we will study about the ocean relief, and then we will move on into the region of the ocean temperature. We will move on into the area of ocean salinity, but we'll do that after the break. So we take a break right now and we come back at 5:30, and then we will continue. Okay, and annual range of temperature means changes in temperature every month. The maximum temperature in the year, minimum temperature in the year, that variation is the annual range of temperature. Okay, so we take a break and we are going to be back at 5:30, and then we will continue.
रहा है तब कहाँ पिएंगे।